Hello, hi students. So how are you? Welcome to our channel Physics to Learn here. In last previous class we have been discussed regarding the Kepler's laws. So now which we are going to discuss regarding the concept of gravitation. That is in gravitation chapter which we are going to discuss about the gravitational force. What is gravitational force? So if you have been seen here, that which it can attract some of the bodies. It is a force of attraction between any two bodies due to their masses. So in class 12, which we are going to learn regarding the electrostatic force. So in the same way, now we are going to discuss regarding about the concept of gravitational force. So this gravitational force which we are going to obtain, so because of their masses. So every object or every body which you have been taken, we are going to get that body will be having some mass. Because of their mass, here which we are going to get the force of attraction. So you can see this is the earth which you have been taken and objects which they are falling towards the surface of the earth. How is it is possible? So because of nothing but gravitational force. So what are the properties of this gravitational force? So which you have been seen, we can get it as the gravitational force between the bodies so gravitational force between the bodies forms an action and reaction pair. So you have been seen that. So from Newton's third law, for every action there is an equal and opposite reaction. So based on that concept, between two bodies we can obtain action and reaction. With the help of this, which you can tell it as they are equal in magnitude but so opposite in direction, so which we can tell it. So this is regarding the gravitational force which we can tell, which we are going to discuss in detail regarding this concept. So gravitational force between two bodies is independent of nature of the medium, but whereas some other forces like electrostatic force which you have been taken, it depends upon the medium, or so magnetic force you have been taken, that also it will depends upon the nature. That means between that which medium is there. But whereas if you come across this gravitational force is the one which is independent. It does not depend on the nature of the medium. So which we can say that. Gravitational force is negligible in case of lighter bodies. So this gravitational force we are going to discuss it for only for heavy bodies. We are not going to consider for lighter bodies. So this gravitational force we can observe in case of massive bodies like stars and planets, but we should not have to consider for light bodies. For example, so if two persons are there, sir, between them we are not able to observe the force of attraction because of gravitational force. Why means, so these bodies are very light, so when compared to mass of stars and planets. And It is the weakest force among the all forces but have longest range. So in at the beginning, fundamental forces, so which you have been discussed, we will be having four. Apart from that, this is the one gravitational force which we can tell, and it is the weakest. It is the weakest force, so which we can take, and it is the longest range force. So these are the two properties of a gravitational force, so which we can tell it. It is a conservative force in nature. So types of forces we have been discussed. We have been discussed conservative force and non-conservative force. This gravitational force which comes under conservative force. So it is communicated through gravitons. So whereas electrostatic force we have been taken the force because of electrons, whereas nuclear force we have been discussed that which we can cross because of protons and neutrons. Like that, in the same way, this gravitational force is communicated through gravitons, so which we can tell that. It is mass dependent and charge independent. So it's a very important. It is mass dependent and which you can call it as it is a charge independent, because mass is always positive. Mass is always positive. So based on that, we can tell it as this gravitational force is charge independent and it depends on mass. If mass is more, gravitational force will be more. If mass is less, gravitational force will be less. So based on that, just you can see one MCQ. So gravitational force is a force of attraction between the earth and any other body, a force of repulsion between the earth and any other body. It is the strongest force. It is a short range force. So please pause the video and try to write the answer, comment below. Subscribe my channel and share to your friends and like it. So gravitational force is a force of attraction between the earth and the other bodies. So which of the following is a property of gravitational force? It is the weakest of all the forces. It has the longest range. It is a mass dependent. But if you see the properties, and last one is all the above. So if you see all these 3 points, so which we have been studied in case of properties of gravitational force. So the answer is nothing but which you can tell it as all the above. So with the help of this, which you can tell it as regarding universal law of gravitation. This universal law of gravitation, it has been explained by Newton. So basic idea for universal law of gravitation you have been taken. According to Newton, moon is revolving around the earth in circular orbit of radius rm, so which they have been taken. So how the moon is revolving around the earth means, because we know that so earth will be having some gravitational force. So based on that, which it can move in circular path. In order to move that, which we require the centripetal acceleration. Due to centripetal acceleration, so which we can be take down. So with the help of this, so in while discussing the concept of laws of motion, you have been proved the centripetal acceleration A is equals to v square by r. Now acceleration of moon we can write it as a v square by rm, but whereas v value, this v value which you have been taken it as velocity is nothing but distance by time, so which they have been taken. So based on this, so they have been taken it as if it completes one cycle, For this, the radius will be the rm. So for one complete cycle, circumference of the circle is 2 pi, rm is the radius, so which they have been taken, and t is the time taken by the moon to complete one cycle. So with the help of this, so if you know the value of time period and distance from center of the earth to the moon, which we can find out acceleration of moon. So with the help of this, squaring 4 pi square rm by t square, so which you can get with the help of this rm gets cancelled, and then we can write it as further continuation as, where v is the orbital speed of moon, t is the time period of moon, which is equals to 27.3 days. So for us, you know how much to complete one revolution, how much time it will take. So based on that 27.3 days it will take the time to complete the one revolution. So rm is the radius of moon orbit, so which they have been taken. It is a standard value, which is nothing but 3.8 into 10 to the power of 8 meter per second. So, and by substituting these values in the above equation, so which you can get it as, so 4 pi square rm by t. So acceleration of moon we have been obtained it as 1.63 meter per second square. So this is the acceleration of moon, so which we can be obtained. So if you have been taken this, the acceleration of earth will be 9.8 meter per second. So depending upon this, the acceleration of moon is very small when compared to acceleration of earth. So am is very much less than acceleration due to gravity on surface of g. So this clearly shows that the force of earth's gravity decreases with distance from the earth. So in detail regarding this, how the gravity it can changes, so based on its height, depth and then rotation. So in detail, which we are going to discuss. So Newton assumed that this force changes inversely as square of distance and calculated the ratio of acceleration due to gravity of earth and the moon. So based on that, so what we can get this. With the help of this, we can prove it as here acceleration is inversely proportional to its radius. Here the radius means which is nothing but distance between the two bodies, so which they have been taken. Here am acceleration of moon, rs so radius, and g acceleration due to gravity of earth, and re represents the radius of earth, which they have been taken. So based on this, by substituting these two values, so which we can get it as the value which you can obtain it as like this. So gm by am, so if you have been done it, so rm square by re square, so which is equals to 3600, so which we are going to get. So this leads to the law of gravitation. So based on that, now which we are going to discuss. So this value is an excellent agreement with the value of g value we know, which is nothing but 9.8 meter per second square, and acceleration of moon we have been taken, so which is nothing but 1.63 meter per second square. So with the help of this, now which we are going to tell regarding universal law of gravitation, it's based on for 3 marks. It is an important question, so which you can see this. So let us consider m1 is mass of body A, which you have been considered, and m2 which is equals to mass of body B. Whenever we are having two bodies of masses m1 and m2, between them we can observe the force of attraction. That force of attraction is nothing but gravitational force. So with the help of this, these two are separated by a distance which you can take it as r. There exists a force of attraction between both the bodies A and B. So this force is called gravitational force. So with the help of this force is directly proportional to the product of their masses. Here product of their masses is nothing but m1 and m2. And this force is inversely proportional to square of the distance between them, inversely. So how much distance between this A and B you have been taken, that which it will be inversely proportional. So F is inversely proportional. By combining these two equations, so which we can get it as F is directly proportional to m1 m2 by r square. To remove this directly proportional, which we are using some constant, that constant is nothing but universal gravitational constant. So with this, so what we can tell the statement of universal law of gravitation. So the same one, so which have been used, so with the help of this equation, so what you have been obtained, we can tell it as, so which is nothing but every particle of matter attracts every other particle of matter with a force which is directly proportional to product means which is nothing but multiplication. So product of their masses and inversely proportional to, so that's which is nothing but inversely proportional to square of the distance between them. So in this manner, so which we can tell the statement of universal law of gravitation. So in order to remove this directly proportional, which they have been introduced a constant, that constant is nothing but capital G. By using that, which you are going to get it as F is equals to capital G into m1 into m2 by r square. So if you have been seen at the beginning, you have been discussed that gravitational force is independent of its medium. So this G is a constant value. So m1 and m2 are the masses and it depends upon how much distance between them. So this gravitational force is independent of charge and it is does not depend on medium, but which depends on the masses, where m1 and m2. So if masses are more, then the gravitational force also it will be the